Okay, so let's take a look at our next algorithm here. And this next algorithm is going to be the peak algorithm. And so what this algorithm is going to let us do is just take a look at the first value in our queue. And if there's something in the queue, it'll return it. So all we're going to need to have access to is going to be the front reference. And so this is going to be very similar to the peak algorithm. It's basically the same thing as with the stack algorithm that we studied previously. So what we're going to do is we're going to check to see if that front reference is not referring to null. And if it's not, then that means there's something in our queue. So you can imagine a picture that looks like this, right? That's our empty queue. And then you can imagine a situation where we've got a non-empty queue. And we're only ever looking at the front, so we don't have to worry about how long the queue is or how long that list is going to be. Now there's going to be some value in there. We'll call it v sub 1. Now if the front reference is not null, which is the case in this second picture, then we're simply going to return that value in our front node. So that's going to be f dot x, right? If x is the member within our node that's storing some piece of information, like say an integer, right? Now, take a look at our first scenario. In our first scenario, f does refer to null, right? So this is going to be false. So we're going to kick down and have to do something else. So that's going to depend on what you're actually trying to implement, right? Now, in the case of integers, you can't just pick some random integer that to return, depending on what types of integers you're storing, right? If you're going to be able to store all integers in existence, well, then you can't just pick one to indicate that something went wrong because all integers are valid, right? So in this case, maybe what you do is, if, depending on what language you're using, you could throw some kind of an exception here. So you could say throw an exception, right? So if you're talking about Java, then you could throw a new exception, for example, and maybe put something inside of here that describes what happened. If you're talking about Python, then you'd be raising an exception. And if you're talking about C++, you'd also be throwing an exception as well. Okay. All right, so let's talk about the performance characteristics of this. And there's not a whole lot going on here, right? So what are we talking about? Worst case, big O, what's going on? So no matter what happens, we're going to be checking that front reference. So that's going to be one operation. Now, if that evaluates to true, we've got to do a return here, right? But let's say that it evaluates to false. Well, if it evaluates false, then maybe we throw an exception. So in either case, no matter if front set to null is true or false, we're only going to do one additional operation. So that means that we're going to do 1 plus 1. So we're always doing the test, or we're doing this, or we're doing this. So that is two operations, which is big O of 2, which we could rewrite as big O of 1. It's constant time. No traversal needed. We're only ever looking at the front reference in that very front node.